Hello statistics students, this is Mr. Cazzato. We're going to discuss two-way tables. So if you read problem number 1, the table here shows the experience level of a hiker, experienced or novice. So that's a categorical variable. And the way they would travel if they got lost, if they go downhill or remain where they're at. That's also a categorical variable. So if you look at question number 1, what is the probability the person will go downhill? So we're going to use this row that I'm highlighting. So the probability, or we use percent in class, that they will go downhill is going to be 51 out of this total 133. When you do that in your calculator, you get 0.38345. And if you were to round to 2 decimal places, it's going to be 38.35%. Question number 2 says, what is the probability the person is novice? So we're going to look at this chart, and we're going to look at the novice column. So these are the people that are novice. And we're going to look at that 61 people. So it's going to be 61 over the 133. Doing that on my calculator, I get 0.45864. And if I were to round the 2 decimal places, 45.86%. Question number 3. What's the probability the person is experienced and goes downhill? So experienced and goes downhill. I'm interested in this yellow column, which is the experienced, and going downhill, the blue. And if you look at my screen, when you combine the yellow and blue, you get the green. So the people that are experienced and go downhill is this number I'm circling. So it's 27 out of 133. 27 out of 133 on my calculator is 0.20300. And if I were to round the 2 decimal places, that's 20.30%. Question number 1D asks, what is the probability or percent that the person is novice? So I'm looking at this novice column, and the fact that they will remain where they're at. So I'm using this blue highlighted row. So I'm interested in all the people that are novice or they remain where they're at. So I'm interested in the 24, the 37, and the 45. Because this word is or, I'm interested in all 3 of those groups. So I would add 45 plus 24 plus 37, and I would divide by that 133. So doing that on my calculator, I get 106 out of 133. That's 0.79699. And if I were to round that, that's going to be 79.70%. So just to review the rounding, this 9 is going to make that go up to 70. So hopefully you found this video helpful. I'm going to show another problem on the screen. And if you want to try this problem, pause the screen, go ahead and try it, and then I'm going to explain it. All right, number 2A, the person is an athlete. So I'm looking at the athlete row there. We can see that there are 101 out of the 188 people are athletes. So doing this on my calculator, I get 0.53723, rounding to 2 decimals, 53.72%. Part B says, what's the probability the person does not eat lunch? So I'm looking at this column, And there's 127 people out of the 188. Doing that on my calculator, 0.67553. That's going to be 67.55%. Part C, what's the probability that the person eats lunch and is an athlete? So eating lunch is the blue column. The person is an athlete is the yellow. Because this word is and, I'm only interested in these 41 people where the yellow and the blue intersect or cross. So it's going to be 41 out of 188. Doing that on my calculator, 0.21808. That's going to be 21.81%. And number 2, we're looking for the probability the person does not eat lunch. So does not eat lunch. That would be these yellow numbers that I've highlighted. And is not an athlete. That would be this row. Because the word connecting here is the word or, I'm interested in every one that's kind of highlighted. So I'm interested in these 20, these 67, and those 60. So I would add 20 plus 60 plus 67, and I would divide by the total, 188. When I do that on my calculator, I get 147 over 188. That's 0.78191. So that's 78.19%. So I'm hoping you found this video helpful for two-way tables.